Yeah.
Okay, finally. Okay, sorry. I
Provide your mic.
uh accidentally end the, the Google Meet session just now because I'm trying to find out like how to share the screen on my iPad because supposedly just now I cannot share the screen on my iPad, so that's why. Okay, but luckily I think everyone can see the slides now, right?
Yep.
All right, okay. So thank God, after I accidentally end the Google Meet session, and when I join again, I can share the slides. Luckily, okay. So yes, today we're going to look at the non-parametric test, which is Krasker-Wallis. Okay. Wait, how many people we have? 3, 6, 9. Okay. All right. So we're going to proceed with the next analysis, which is non-parametric test for one-way ANOVA. So last time we've already looked at one-way ANOVA. So just as a simple revision, one-way ANOVA is where let's say you have more than what do you call that? Because in t-test, let's say when you're doing t-test, you only have one factor, right? You only have one factor or one variable, okay, which you have few groups, right? But in one way ANOVA, you have several, you have two, okay, you have two factors or two groups or three groups and more. Not yet. That one is two-way ANOVA. You have three or more groups. Let's say in t-test, okay, in t-test, let's say you have gender. So you have male and female. So but in ANOVA, let's say if you have um few groups. Wait. I have to share the screen again. Okay. Okay. Let's say in t-test, you have gender, so you have male and female only. So you have two groups. But in one-way ANOVA, the analysis for one-way ANOVA occurs when you have three groups, such as when you are analyzing the differences between um, set 1 of this class, set 2 of this class, and set 3 of this class. So you have three groups, but still, you still have one factor. Okay, you still have one factor, which is gender, or not gender, class, or maybe states, right? Like Kedah, Selangor, and Kelantan, and Terengganu. So let's say you are comparing the performances of your students there. So when you have more than three groups, then you can use one-way ANOVA. Okay, so like I said, like we have seen in t-test before, we have the alternative test. Okay, the alternative test, or we call as non-parametric test. In case if you don't have like normal distribution of the data, or you didn't fulfill the assumptions that you need to fulfill, okay, in order for you to conduct the parametric test, whether it's t-test or ANOVA and so on. So in the case of ANOVA, if you didn't somehow fulfill this assumption, this one, okay, independence of observation, normal distribution, homogeneity of variance, and so on. So if you didn't fulfill these, meaning that if your data is not normal, if your data doesn't have the homogeneity of variance, if your data doesn't involve independence of observation, you cannot use one-way ANOVA, and you have to change your analysis to the non-parametric test. Okay, the non-parametric test for one-way ANOVA is what we call as Kruskal-Wallis. Okay, Kruskal-Wallis test. So Kruskal-Wallis test, you can see here, it is used to compare three or more samples. So the same as ANOVA. Okay, the same as ANOVA. So you cannot use Kruskal-Wallis if you only use two groups. If you use two groups, you can go for the non-parametric test for independent sample t-test. Okay, and then if let's say you are not using ratio or interval, you have ordinal measurement scale. So you can use the Kruskal-Wallis. And then uh, basically, if you didn't fulfill the assumptions of one-way ANOVA, you can use these as alternative to one-way ANOVA test. And each sample has at least 5 observation. What is 5 observation? 5 observation meaning that you need to have at least 5 sample. Okay, to use one-way ANOVA. But then you somehow, when you collect your data, you are not able to get the right number of sample or enough number of sample, which is less, which is not less than 30. Let's say you when you distribute your questionnaire, whatever your instruments, and then you find out that only 8 people or only 10 people answers your questionnaire, then you have to use the Kruskal-Wallis test. And also, in Kruskal-Wallis test, it is totally different from one-way ANOVA, because one-way ANOVA, usually we will use mean as the basis of the analysis. However, for Kruskal-Wallis, we use rank. Okay, ranking. We use ranking in order for us to analyze. So that the basis of Kruskal-Wallis test is actually ranking of the data, not the mean of the data. Okay, so that is what makes Kruskal-Wallis difference from one-way ANOVA test. So Kruskal-Wallis test also have assumption. Okay, also have assumptions. So the first assumption is the dependent variable should be continuous interval level. So it can be continuous, which is interval ratio, or it can also be ordinal level. And the independent variable should have 2 or more categorical independent groups. Okay, so you need to have more than 2. Okay, and then assumption 2, you should have an independence of observation. This is also the same. So basically, if you are looking at, you know, 2 different groups, whether it t-test or ANOVA, any comparison between groups, you need to make sure that there is a relationship, there is no relationship between observations. So like I mentioned before, if let's say one of you, I want to test, I want to see the differences between this set and also the other set, okay, another set, and maybe another set, so 3 sets in total. On what is your performance when during the quiz for this courses, okay, for these courses. So let's say I will give all 3 sets quizzes, and I want to see which groups perform the best. So I need to make sure that nobody in each group are participating in another groups. Okay, so there should be independence of observation. And then the distribution of scores for each group have the same shape, have the same variability. The variance should be similar. This is what we call homogeneity of variance. Okay, these assumptions is what we call as homogeneity of variance. Homogeneity of variance. Okay, so next, this is actually the hypothesis for Kruskal-Wallis test. Okay, all populations have the same distribution. This is for H now. And hypothesis alternative is not all populations have the same distribution. So this is what you need to write for the hypothesis for Kruskal-Wallis test. So hypothetically, this is the formula for Kruskal-Wallis test. That before this, you have to learn how to calculate using this formula. But now, you don't really need to, learn how to calculate it manually. But you just need to understand in what situation you need to use Kruskal-Wallis. Okay, so Okay, so let's look at the example here. Okay, so here you can see that this is the class size for maths, English, and history. So here we can see that this is group 1, this is group 2, and this is group 3. Okay, so here we have 3 groups. And how many observations you have here? Can you tell me how many observations you have for each group? Anyone?
5.
5 observations. Okay, so you have 5 for math, 5 for English, and 5 for history. So here we can see that it fulfills the assumptions lah, because we have at least 5 observations for each group. Okay, so here we can see that if you look at here, this is the data for each group. Okay, so here you can see that what they ask you to do is find the median. So you can see what is the median here. Okay, can you tell me what is the median for math, what is the median for English, and what is the median for history? What is the median value?
Math is 54.
Math is 54. Okay,
The middle value.
okay,
So
so what is the median for English?
72.
Are you
wait,
sure 72?
no. Wait, it hasn't been arranged.
Are you sure 72? What is the median for English?
60.
60.
60. Okay, first you have to arrange it to the the ascending order. Okay, and then you can pick the range, the median. And what is the median for history?
34.
34. Okay, so this is the median. So you can see here that first, the hypothesis null is saying that all 3 sections have the same median class size. And the hypothesis alternative is saying that not all sections have the same median class size. Okay, so do different sections have different class sizes? So we can see here that manually it doesn't have any it doesn't have the same median, right? So yeah, so that is basically what we need to do for the or understand what we need to understand for Kruskal-Wallis. Basically it is the same as as one-way ANOVA. However, like I said before, it doesn't use mean. Okay, it doesn't use mean. And the thing that you need to know now is to use SPSS to calculate it. Because later we will learn how to interpret like this one. We will learn how to interpret the Kruskal-Wallis test. So I think the easiest way to understand Kruskal-Wallis is just whenever because okay, when you are doing research, usually in the earlier part of your doing the research, you already have the plan. Okay, let's say, okay, I want to use for the first objective, I want to use t-test. For the second objective, I want to use ANOVA. Or for third objective, I want to use correlation. So usually you have all this in your mind already. Okay, because when you do the problem statement, you will find out what is the variable, and you will find out whatever you want to find in your research. Let's say you want to find differences, you want to find relationship, you want to find the impact. So from the problem statement, you already know what you want to find. Okay. However, there are 2 situations where you have to use this non-parametric test. Okay, the first situation is in the beginning, you plan to use ANOVA. And somehow when you test the assumption, like I said before, normality, homogeneity of variance, and so on. So when you test the assumptions, you find out that you didn't fulfill the assumptions. Okay, in that case, you have to change to Kruskal-Wallis. The second what do you call that? Second way is when you know already from the beginning that your sample is not large. Okay, so let's say you are doing a research on a sample that is very scarce. You know already that your sample is very, very little. Like maybe out of billions of people in Malaysia, the population that you want to study only have like maybe 15 people, right? Or 30 people, or maybe 40 people, which is impossible for you to get everyone to be your sample. So maybe in that case, you can decide already from the start that you want to use Kruskal-Wallis. But this second case is very rare. Usually for us, especially for us social sciences, usually our population will consist more than thousands of people. So that's why I focus more on what you call that you did not fulfill the assumptions for ANOVA, then you have to resort to use the Kruskal-Wallis. But in case if you are doing a research towards a very small population, very small, I mean very small meaning that it's like maybe out of billions of people in Malaysia, maybe you have 40 people only throughout Malaysia or 30 people throughout Malaysia, okay, and you want to study maybe something like maybe what do you call that differences between them, or maybe you have 60 people, you want to divide into few groups, you know, so it's very impossible for you to get more than maybe 30 people for each group. So then you can easily choose from the beginning that you want to use Kruskal-Wallis. Okay, so that is how you decide that you want to use Kruskal-Wallis. Okay, so using SPSS, can everyone open their SPSS? Okay, so using SPSS, we are going to use this data set. Okay, we are going to use this data set. Okay, so like we have did before, I think everyone still remember how to put the data into SPSS. So what you need to do now is key in the data into your SPSS. Okay. Okay, wait. Wait. Okay. I'll share from here again the data. Okay, so everyone can open your SPSS and you can refer to this, okay? To this data. So first of all, like I mentioned before, go to the variable view and put the name of the variable lah, okay? Class size. So from there, you can put okay, you can pick the values and you can put the 3 values there, which is first is 1, second is 2, and third is 3. So you can put the first one is math, second one is English, third one is history. Okay, and then the second one is the marks. Okay. So measure should be, the first one is nominal, second one should be scale. All right. So you go to data view. So you input all the data 23, 40, 41, 54, 78, 66, 55, 60, 72, 45, 70, 30, 40, 18, 34, 44. Okay. Okay, so I think everyone can see the screen, right? Okay, so have everyone finish inserting all the data? Okay, everyone finish? Is everyone done? Can you hear my voice? Can you hear my voice?
Yes, doctor.
Okay, is everyone done? Not yet?
Just a bit slow.
Okay, it's okay.